Hey everyone, this is Soren. So Kays recently did a video on the Mario 64 sound engine, and he briefly talked about a dynamic sequence I wrote which switches between versions of the credits theme as you move through the level. I wanted to go into more depth about how this sequence works and why it's so elaborate. After all, what's so hard about fading between different versions of a song? Banjo-Kazooie did this, for example, in Gruntilda's Lair. Yoshi's Story uses this mechanic for the invincibility effect in nearly every track in the game. And Ocarina of Time's Hyrule Field goes a step further by dynamically selecting between different sections of music every few measures, based on whether Link is fighting, running, or standing still. How can I claim that my song is more advanced than all of these? Before we get to that, I want to talk about some background which Kays skipped over. This sequence scripting language, which is used in Mario 64 and the other first-party N64 games, has a name. It's called Music Macro Language. Now, Music Macro Language is like assembly language. Sure, it looks like assembly language, but I don't just mean that. You can have assembly language for two different architectures. The instructions might be completely different, and a programmer skilled in one might not even be able to read the other. It's the same for Music Macro Language. It's not a single language specification, it's a kind of language. For example, this is what a song on SNES looks like, and this is some of the actual music code from my song for N64. I don't have any idea what's going on in the SNES music here. The word macro in Music Macro Language comes from Macro Assembler. This is a program which converts this text-based sequence to a binary representation. It does so by defining macros. For example, here the chan set vol command puts the byte df in the output, then takes one byte argument which it puts in the output after that. This also means you can have different text representations of the same sequence data. Basically, you can name each of the commands whatever you want. Myself and the Mario 64 decomp community use different names for the commands, and both are different from the names Nintendo originally used. But as long as you can convert backwards from binary to text, more on that later, the text representations are equivalent. The big difference between Music Macro Language and assembly language is that the binary form of assembly, machine language, is directly executed by the hardware in a chip, whereas Music Macro Language is interpreted by code in the audio engine. This is the code that Kays was talking about making big changes to in his recent videos. This code ultimately defines the capabilities of this specific version of Music Macro Language. To continue the example I just talked about, if it sees df next in the sequence data, it reads one byte and then sets the channel volume to that value. There's commands like this for playing notes, changing instruments, tempo, vibrato, and all kinds of other music things like that. But there's also commands for reading and writing memory, doing some very simple arithmetic, and branching and calling subroutines. So you can think of it like a combination of a MIDI file and a Turing-complete programming language. So now that you have some background on the format, let's talk about how I got involved in making this song for R2II. I wrote the tool which the community uses for editing music in this format, called Seek64, starting 11 years ago. That's right, I spent Thanksgiving weekend 2014 reverse engineering disassembled Ocarina of Time sequence parsing code to figure out what some of the commands did that the community didn't know yet. At the time, nobody knew this was Music Macro Language, or how far its scripting capabilities went. I was mainly focusing on MIDI import-export, to rip the soundtracks and make new music for ROM hacks. Eventually, I added full three-way support for converting between MIDI, text-based assembly, and binary. By the way, importing binary requires semantic understanding of the sequence contents. It's not just converting the commands one by one to their text equivalents. For basic commands like the channel volume we talked about, it really is that simple, but once you start performing table lookups and indirection, you have to track the structure of the sequence. This is something that the Mario 64 decomp community was not able to do. They hard-code certain information about each sequence to avoid this, and so they aren't actually importing arbitrary binary sequences. Anyway, so I had worked on Seek64, and I understood the Hyrule Field sequence as well as the sound effects sequence for Ocarina of Time. But besides making new sound effects, and that example Kays showed where a sequence breaks out of the interpreter to get arbitrary code execution in the game, nobody is writing new sequences in this language. Sure, people are using Seek64 to convert MIDIs to sequences, but nobody's actually writing sequences by hand to implement new dynamic music. In other words, there's untapped potential here that I've known about for years. So Kay's made a video introducing one of the nostalgia levels in RTYI, where you go through parts of all 15 courses from Mario 64 in one big level. He had the credits music playing, but when you get the wing cap halfway through, it interrupts the credits music and changes the mood. There was a comment thread under the video, asking if the music could switch to a wing cap version of the credits theme instead. I saw this and started thinking even bigger. What if we had versions of the credits theme for all the level themes? I thought about some of the technical challenges, which I'm going to describe in this video, and because this was such an interesting challenge for Music Macro Language, I wanted to work on it. I got Kay's permission to get started, and it took about a month or so to do the arranging plus the technical sequence work. So let's get into it. What's so complicated about fading between different versions of the song? The problem is that there are 8 different versions. The credits theme arranged like the main theme, water levels, snow levels, ghost house, underground, lava sand levels, wing cap, and slider. And both MIDI and this version of Music Macro Language have a limit of 16 channels. We could change the format to add more channels just by editing the sound engine code which interprets the sequences. But that would break all existing sequences, because many of the command definitions would need to change to accommodate more channels. And even if we did that, music editing software, like Reaper or FL Studio, is limited to 16 MIDI channels. You can have hundreds of tracks, and you'll virtually never be bottlenecked by MIDI channels in modern music production, but when using modern software to edit MIDI, you still have that limitation. So it would be hard to actually create any music with more than 16 channels. And finally, even if we solved that problem, you'd have 40 or 50 different channels playing at once, which would consume a lot of resources on the CPU and RSP. So since we'll stick with the 16 channels, since we have 8 versions, that means only 2 channels per version. Since one channel can be only one instrument at a time, that basically means 2 instruments per version. This is not workable. These themes, which I'm trying to copy the style of, tend to use about 4 to 7 instruments at a time, assuming you count all percussion as one instrument. I'm pretty sure the way Banjo-Kazooie gets away with this is that it only has 3 or 4 versions of the music loaded in each room, and each only uses a few instruments, so it actually can fit them all into 16 channels. But for the RTYI song, this is never going to fit. This means we cannot just be playing all the versions at the same time and fade between them. We have to be more clever than this. So I broke up the 16 channels into 2 groups of 8 channels, and I have only 2 of the versions playing at once. So each version can use up to 8 instruments at a time, which is enough, and I can still fade from one version to another. Then, once I've faded, I can swap the version which is not playing anymore for the next version, and get ready to fade to that when needed. Sounds simple enough, right? Well, the problem is how to synchronize the different versions. I can start with versions 1 and 2 playing synchronously, but once I fade from 1 to 2 and I want to swap out 1 for 3, I want to start playing 3 at the same musical time as where 1 was playing. There's no fast forward or skip ahead in time command in this language, and if we added that, it might cause a lag spike when it was used, because it would need to process a huge amount of sequence data all at once. Plus, in order to know what time to skip to, we'd also have to add commands to track the current time and do math on these time values. Here's the clever solution. I break up the song into sections. This is an orthogonal concept to the versions. The sections are what part of the song is playing in time. In other words, the first section is the first 8 measures of the song, the next section is the next 8 measures, and so on, just like in Hyrule Field. Then what happens is, I fade between versions, but I don't then swap out the non-playing version immediately. I swap versions only on the section boundary, because I can have it jump to the beginning of a section. The 8 measure sections also bring another benefit. Some of these sections in the song are repeated, so we don't need to encode them twice. In other words, there is a linear section index, which just increments from 0 to 15 and loops back to 0 as the song plays. And then there is a map from this number to the structural section index, which is the actual data to be played at that time. It turns out that 4 out of the 16 sections are repeated, so this saves a quarter of the total data, with only the cost of one table lookup. Finally, as Kay's mentioned in his video, what happens if the player falls down to an earlier part of the course which we didn't have the version ready for? Or what happens if they do a BLJ and skip to a later part of the course? We could just queue up the change to occur at the next 8 measure section boundary, but I wanted the music to be more responsive than this. So instead, I have the song cut from wherever it was to one of 2 jingles, a power-up style one if you skip forward, and a power-down one if you fell. It plays that and then jumps to the start of a section for the correct version for where you now are. Which section, you ask? If you powered up, it actually goes to the start of the next section, and if you powered down, it goes back to the start of the current section. This is just subtle psychology for you skip forward versus redo the part you just did. Now that's a lot to keep in mind, but remember, this is all being implemented in the music script itself, in this extremely rabbit hole assembly language where there's only 4 bytes of memory per channel, the only arithmetic instructions are subtract and logical and all the channels are executing the code in parallel like a GPU. Remember when I said I only took this on because it was going to be enough of a challenge? Let's talk about the implementation. The first step is to set up infrastructure so that we can get 8-channel sequences to play on either channels 0 through 7 or 8 through 15. It's not just the playback itself, it's the memory. For example, I've set up the memory for channels 2 and 10 to hold variables about the state of that group of channels. So all the channels need an instruction like, load this byte from channel 2 if I'm channel 0 through 7, otherwise load it from channel 10 if I'm channel 8 through 15. These kinds of instructions don't exist in the language, but with self-modifying code, which the language relies on heavily, we can make them. When channel 0 runs, it edits a list of instructions in the sequence to refer to channel 2, and then when channel 8 runs, it edits those same instructions to refer to channel 10. The channels are always executed in order on each tick, so this works. The next step is to build a finite state machine, which is executed by channels 0 and 8 to determine what their channel group does. This means watching for changes from the game engine for which part of the course Mario is in, incrementing or decrementing the volume to fade in and out, selecting the next section, and interrupting the music to jump to one of the jingles. And some of this code has to differ between channels 0 and 8. For example, one of these will fade out while the other fades in. All the channels besides 0 and 8 execute a simplified version of this code, which just sets their own volume and moves to the section determined by channels 0 and 8 when applicable. Finally, we need code for handling the intro and ending, which are both organized as multiple sections, each of which loops dynamically until Mario takes some action in-game. This is simpler than what I've been talking about, because there's only one version and the section either loops or continues, but it's still a bit tedious and has to interact properly with the main code. In total, there are 108 sections, counting the versions separately, and 456 individual 8-measure channel snippets. The song is nearly 15 minutes long with all the versions and sections laid out start to finish. There's over 400 instructions of dynamic music code, not counting hundreds of lines of tables, and the music itself is almost 14,000 instructions. After all these years of working on the tool for this format, and knowing what it was capable of, I'm so glad I got the chance to make a sequence that uses it to its full potential. I hope you're looking forward to playing this level in RTYI whenever it eventually comes out. Subscribe to Kays if you're not already. Thanks for watching.